أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. In the lecture series of Material Studio, we are at lecture number one, and in today's lecture, we will discuss about geometry optimization. So basically, geometry optimization and GFT is the process of finding the most stable atomic structure of a system by minimizing the total energy with respect to the atomic position. And in simple term, it is like adjusting the atom's position until they are comfortable and the system energy is lowest. So it is necessary to do geometry optimization before calculating properties, because properties like electronic structure, charge density, or optical responses depend on the atomic structure, and optimized structure ensures a more accurate and reliable properties calculation. So, meaning that at first we must do geometry optimize, and then we will do calculation of our properties like band structure, density of state, and optical properties, elastic constant, or some thermodynamic properties. Okay, so in our courses we discuss um, we will learn about band structure, density of state, partial density of state, optical properties like optical absorption, optical conductivity, optical reflectivity, and refractive index, and so on. Along with it, we will also learn about um, elastic constant, and then we will then learn about vibrational analysis. I mean phonon calculation, and in phonon we will also learn about entropy, free energy, divide temperature, and heat capacity. So this is the overview of our course. Let's learn, and yes, we will learn pure practically. Okay, so this is the interface of Material Studio. Okay, so before starting calculation, the DFT calculation is in three steps. At first, we have to model the desired structure, and then after that, in the second step, we will do a calculation, and in the third step, we will do analysis. So to start geometry optimization, we must have one model. Okay, as an example, I have one perovskite material. This is the crystallographic information file. Okay, you can download very easily from the from Material Project, Material Explorer, or you can build. We have option. We can build it very easily if we have desired information. Okay, so this is the um, a perovskite, a double perovskite structure I have, and I will start geometry optimization. I will show each and every step that how to run geometry optimization for any structure, and keep in mind these steps are I will teach you generally. Okay, so you can use the same step for metal oxide, for hydride, for perovskite, for double perovskite, or for example for metal, you can use. Okay, and so this is my CIF file of my perovskite material, and at first what I can do is to I will set the visualization of this model. So I will set it to ball and stick mode. Okay, but this is just for the visualization purposes. Okay, so now I can see my structure very clearly, and after that I will do geometry optimization. So for starting calculation, click on modules, and within module we have 21 or 22 different module, but we will use case step. Okay, we will use case step. So once you click on module, you will have these all these module, and in these select case step. Okay, so here we have a four different tab. The first one is setup, electronic, properties, and job control. So we will set these step by step to do geometry optimization. So since our aim is to optimize this structure geometrically, so we should set our task to geometry optimization. Okay. And within the quality section we have five different qualities, but we will do calculation. Mainly we do calculation with fine and ultra fine qualities. Okay, so it's better to always choose fine quality. Okay. And within function we have a generalized gradient approximation and local density approximation, and we also have some hybrid function. So better is to, and while doing calculation for hydrogen storage, better is to pick GGA always. Okay, GGA with PBE. If you have good computational resources, then if you choose hybrid, it's okay, it's still okay. But if you are limited with computational resources, the best choice is generalized gradient approximation, I mean GGA PBE. Okay, so also if you want to do calculation, spin polarized calculation, so open spin polarize like this, and if you are doing non-polarized, so it's okay. So it's better if you are just taking as doing calculation, I mean writing a paper, you want to do calculation for hydrogen for the purpose of hydrogen storages, so do calculation with non-polarized. Okay, since this is a semiconductor material, it's not a metal, so I will must uncheck this. Okay. Okay, after that, I have within setup section, I have more option. I have one more tab. So I will must set this minimizer option and stress option. Okay, so within minimizer, we have a convergence tolerance with the quality, energy, maximum force, maximum stress, and maximum displacement. But no need to change these manually. Okay, so if I change the quality, all these energy, maximum force, maximum stress, and displacement change automatically. You can observe, you can see the energy has been changed automatically. So when I set fine quality, so I got these energy, force, and stress values. Okay. Here we have an option of cell optimization, which is initially set to none, but we want to optimize geometrically optimize our structure, so we want full optimization, so must select full from here. Okay. And within the option section we have a algorithm, and always use BFGS algorithm. Okay, BFGS, it must be BFGS in any type of calculation. So since initially we are not interested to check to apply any pressure, we will go with zero pressure. Okay. After that, we have to set the electronic tab. Since from here we already select the fine quality, so no need to change the quality, just change the pseudo potential. Okay. So for since we want to calculate the band structure, density of state, and optical properties, so for these type of electronic structure calculation, you should select ultra soft. Pseudo potential should be ultra soft. Okay, keep in mind this is very necessary step and important. If you are go with non-conserving, you will get unreliable results, which will definitely be inaccurate. So you will must go with ultra soft pseudo potential. And also we have a more tab over here within electronic section. The first one is basis, SCF, K point, potential, and DFTD. So within basis, if you want to change the cutoff energy, you can change it manually, but here at this moment there is no need to change the cutoff energy. And we also have self-consistent field. uh, no need to change anything here. Okay, just leave as it is. And also NK point, leave as it is, no need. And potentially and DFT, basically these two tab as for the purpose of surface study. If we do calculation for catalysis, like for oxygen evaluation or oxygen reduction, then we use these two tabs. Okay, but keep in mind, no need to change anything here because we already set the fine quality. So all these parameter are set automatically. After that, we have a property section. Since at this moment we are just doing geometry optimization, so no need to select anything from here. Just deselect everything from here. Okay. We will select these option once we perform geometry optimization. Okay, so within the job control here, we I have 8 cores. I don't know about your system, but better is to apply maximum core. So I apply 8 out of 8 cores. Okay, and click on more. Check these two box. So it will show the job description over here after geometry optimization. Okay, so let's learn. Let's revise all these steps very quickly. As you know, at first we have a setup and we select task geometry optimization. Quality should be fine. Function should be GGAPB for the hydrogen. So since we are our aim is to learn hydrogen storage capacity for these materials, so must select GGAPB. For spin polarization, keep this off, non-polarize, and since this is not a metal, so we uncheck this box. After that, we have a more option over here, and within more, you must select the cell optimization should be full. Okay, and within the option section, the algorithm should be BFGS. Yes, the second one. These are very necessary steps, and the stress should be zero. No need to apply any stress. Okay, after that, and within an electronic section, I told you no need to change anything. Just keep in mind, C2 potential should be ultra soft. Okay, if you apply with go with non-conserving or OFTG, then you will get inaccurate result. While doing calculation, electronic properties calculation, we must optimize our structure with ultra soft. Okay, and no need to select everything from here from property section. And within job control section, select maximum core and then simply run the calculation. Okay, here the system says converting to a primitive cell will significantly improve the speed of this calculation. If you want to make this a conversion, choose yes. If you want to proceed with conventional cell, choose no. So since we are interested to do calculation with conventional cell, not with primitive unit cell, because primitive unit cell disturb our initial geometry and we get inaccurate results. So must go with no option. Okay, just wait for a while. Okay, so you see in the description section my calculation has been starting, and here I also see that my calculation is being started. So it will take like 10 15 or 30 minutes or maybe 1 hour. Some calculation take 2 3 hours, and some calculation take 4 5 hours. So uh, um, uh, we will wait until when the geometry optimization is finished. After that, we will do calculation, properties calculation like band structure, density of state, and optical properties. But at first, all the properties are directly related with geometry optimization. If you are if you optimize your structure uh, in a good way, I mean accurately, then you will definitely get then you will definitely get a consistent result with literature. So keep in mind, geometry optimization is very necessary. All the other calculation is very easy to handle. So that's why I prefer to keep special focus on geometry optimization. Okay, with this, thank you very much. If you have any question, just okay. So you see my calculation is being starting, and I see running. I will send this model to you via email, and please perform the same calculation, repeat the same calculation, and let me know if you have any question or if you face any problem. Just take picture and send me by WhatsApp. With this, thank you very much. Take care.